Hello, grades of. Welcome once again to these sessions. Today we're going to be focusing on geometric sequence. Don't forget, we are still doing grade 12 mathematics summer lesson, and this is just the head start. And this is session 2 of our session. So in session 1, we were focusing on arithmetic sequences, and today in this session, session 2, we'll be focusing on geometric sequences. Don't forget, this is still grade 12 online mathematics. Let's go. Okay, let's take a look at the content outline. And if you notice, I also posted this on the previous session, or session 1. And I will always keep on posting this just to remind you of the lesson objective that need to be met every time when we create these sessions. So today we will be focusing on geometric sequence, as I said, because this is session 2. And if you check on your course outline, here it will be what? It will be our unit 2, right? So we'll be focusing on unit 2. We did unit 1 in session 1. So this is unit 2, and it's our session 2 where we'll be focusing on geometric sequence. So on Friday, that's when we'll be doing the sum of arithmetic sequence. I'll actually move it to Tuesday because Friday it's sort of like Christmas Eve, so we can just give you guys some rest. So today we just really gonna be focusing on geometric sequence. Don't forget, we are getting this content, examples, and activities from Platinum Mathematics Learner's Book. Okay, great stuff. Let's quickly move and do our focus for today. It's unit 2, just as I said, and we'll be focusing on geometric sequences. Geometric sequences. So I don't know if we did this on grade 9 or it's a new content. So I'm not really sure if it was covered on previous grades, but let's take it for as like it's a new concept, because I think grade 9 also it's quite far from grade 12 a bit. So geometric sequences, like I said, before you start a topic, you must understand what it means. So this is very key in understanding the example. How are we solving these questions, and from which knowledge are we getting all this? So if you check, I put a definition of a geometric sequence, very different from arithmetic sequence. So a geometric sequence is a sequence of numbers, right, whereby the next term, very important information, is determined by multiplying with a common ratio on the previous term. So in a geometric sequence, we get the next term by multiplying the previous term with what? With a common ratio. So very different from arithmetic sequence. We said in arithmetic we get the next term by adding a common difference. But now in a geometric sequence, we get the next term by doing what? By multiplying with a common ratio. So there are some keywords there. It's multiplying and a common ratio, right? Keywords in arithmetic, it's adding what? A common difference. But now here we don't talk about the common difference. We have something called the common ratio, same ratio, right? So we have to find that ratio. We multiply it in the previous term to get the next term. So they showed you here, if we have our first term as a, you already know first term is a, right? So to get the next term, we'll multiply the previous term with a common ratio. So the symbol for a common ratio is small letter r, right? So it's small letter r. So that is a common ratio. So let me indicate it here also to say this is a common ratio. So this is a common ratio. So we are going to say a multiplied by a ratio, then we get ar. So it's the next term. Ar times r, it will give you what? Ar squared. So you can see that the next term are being found by multiplying the previous term with a common ratio, right? Very important. So let's also talk about the general formula of a geometric sequence. The general formula of a geometric sequence. The general formula says Tn is equals to a into r exponent n minus 1, right? So very different from arithmetic sequence. This one is Tn equals to A into R exponent n minus 1. So you already know that R is what? Is the common ratio. And how do we get the common ratio? We get the common ratio by saying Tn over Tn minus 1. What does it mean? We are saying the following term divided by the previous term. So that's how we get the common ratio. So it must be T2 divided by T1, which is the same as T3. What is the previous term is T2. So we'll say T3 divided by T2. So once we do that, we'll get what? The common ratio. So you know that A stands for the first term, which is term number 1, and N, as highlighted in red, it stands for the position of term. And we also said it in the arithmetic sequence that N can only be a natural number. That is, N can only be 1, 2, 3, 4, 5, 6, 7. So those are all natural number up until 10, 11, 12, up until positive infinity, but which is a positive whole number. So N will always be that because its position. N can never be negative because N represents a position. We can't say someone is standing on position -1, right? It's always an element of a natural number or a positive whole number. So Tn, obviously we've said it before, it's a general term or the nth term, or what we call the general formula. So this is a general formula for a geometric sequence, not arithmetic, because here we are talking about the geometric sequence. So it's a general formula for geometric sequence. Don't forget, it says Tn is equals to A into R exponent n minus 1. So that's the general term for a geometric sequence. Okay, so let's quickly look at some of the examples and different ways in which they can try to test you on the knowledge about geometric sequences. Okay, great stuff. Let's look at the worked example number 1. We are still doing geometric sequences. Okay, so it says consider the sequence 96, 48, 24, 12 to infinity. So they said, the first question said, state the values of the next 3 terms. State the values of the next 3 terms, right? They need the next 3 terms. Okay, so because this is a geometric sequence, we know that in a geometric sequence, to get the next term, we multiply the previous term with a common ratio. That's the key thing that you must know. We multiply the previous term with a common ratio. So the first step would be for us to calculate the common ratio that we said it's represented by small letter r. So to get it, we said the following term divided by the previous term. So this must be the same as T3 divided by its previous term is T2. So we're going to substitute them. It's going to be term number 2 is 48 divided by term number 1, it's 96. This must be the same as term number 3, 24 divided by 48. So 48 divided by 1 of by 96 is 1 over 2. Now calculator, 24 divided by 48 is also 1 over 2. Therefore we can conclude the common ratio is what? It's 1 over 2. So 1 over 2 is our common ratio. Now we can get the next terms. How do we get them? We multiply the previous term with the common ratio. So to get the next 3 terms, we are going on 12 there. We say 12 multiplied by the common ratio, which is 1 over 2, it will give us 6. So that's the first next term, right? It's the next term. Then we go on 6 as the next term. We multiply by 1 over 2. We get the other next term, right? Like that. We go 3. We multiply by 1 over 2 to give us 3 over 2. So these are the 3 next terms, right? So after 12, we know that there will be 6, there will be 3, there will be 3 over 2. So those are the 3 next terms. Okay, let's look at the second question. Very interesting. It says determine the formula for the nth term of the sequence. So they need what? The nth term, which is also known as Tn. So the nth term of a geometric sequence is the same as A into R exponent n minus 1, right? exponent n minus 1. We must know our a, we must know our r. But you know, we already calculated r. We said our r was what? We got r as 1 over 2 in the previous question. So r, we know it is 1 over 2. Even a, we know a, it's what? It's the first term, which is 96. So we can go and replace them and get our nth term of the sequence. So it's a, which is 96 into 1 over 2. It's our r, exponent n minus 1. So this is the general formula of this geometric sequence. Okay. Okay, let's move to question number 3. They said determine the value of the 10th term, right? Determine the value of the 10th term. So what do they need? They need term number 10, right? So where there is n, we just simply gonna substitute with 10 because they want the value of a term that is in position number 10. So n is equal to 10. So on our general formula, which is 96 into 1 over 2 n minus 1, where there is n, we're gonna put 10. So it's 10 minus 1 because it's n minus 1. Then we're just gonna simplify that and get the answer of our 10th term, right? So our 10th term, when I use my calculator, it's giving me 3 over 16. So 3 over 16 will form part of our 10th term. Okay. Okay, let's now move to question 4. Which term has the value of 3 over 64? What do they need now? Which term? They need what? The term number. So to say which term, we don't know the term, that's why we are putting n, has the value of 3 over 64. So we need to calculate n to see which term, the number of term or the position of term that has the value of 3 over 64. So our Tn will be 3 over 64, but we know our Tn is what? 96 into 1 over 2 exponent n minus 1 is equals to 3 over 64. Then we can solve for n. So solving for n is just applying some algebra and knowing the laws of exponents. So to say how to solve if we have something like this. So basically, in order to solve here, I'm just gonna divide both sides by 96 and to cancel that 96 and that one here, I'll be left with 1 over 2 exponent n minus 1. So 3 over 16, is it 64? It's 3 over 16. Sorry about, oh yeah, it's 3 over 64 because they say the value of 3 over 64. Sorry about that. So 3 over 64 divided by 96. So it's giving me 1 over 2040. 1 over 2040. Right? So to solve for n, we have to make sure that both on the left hand side and on the right hand side we have the powers of the same base. So we must make this 2040 as the same like having the base of 2 so that we may be able to have those powers of the same base, right? So in order to do that, you use your calculator. You want to make this 2040 to be like 2 exponents something, right? So what you do, you use your calculator, you press 2040, then you press equal sign, then you press shift, then after that you press this button that has this sort of like a comma, what, but on top it's written fact. It's written fact on top of it. If you are using a Casio calculator, it's written fact. So what you do, you say 2040 is equals to, you press equal sign, it will show you 2040, then you press shift and you press that button that has like fact there. So it will show you what uh, 20 and 40 is in terms of like having the base of 2. Okay. Okay, so I think I just make a slight mistake here. So this is 2000 2048, not 20,040. I mean 2040. So it's 2048. So you do the same. You just use your calculator. You say 2048. You press equal sign. You press shift and you press fact. Then it will show you that thing as an exponent. So it's showing me 2 exponent 11. So it means we can write it in that way. So it will be 1 over 2 exponent 11. We know 2 exponent 11 is the same as 2048, right? So now we can make the base to be the same. So we know that 1 exponent any number is still 1. So we can write it as 1 over 2 all exponent 11, because we know it will be 1 exponent 11 is still 1, 2 exponent 11 it's returned back to 2048. So now the base are the same. According to laws of exponents, we equate what? We equate the exponent. So n minus 1 will be equals to 11, then n will be equals to 11 plus 1. This will give us what? 12. So our n is 12. So which term has the value of 3 over 64? We know that is term number 12. It's term number 12. Okay. Okay, let's now look at the worked example number 2. And in this example, you are actually given your geometric sequence in terms of uh, variables. Like here, it's in terms of x. And obviously, the first question that they will ask you is that solve for x, and they actually saying show all necessary calculations. So if you check it, our session 1, we also had this question in arithmetic sequence, and we said to solve for x in arithmetic sequence, we know that we have a common difference, then we create the difference and we solve for x. But this is geometric sequence, right? It's very different. Here we don't have a common difference, but we have something called the common ratio, which is denoted by r, right? So we know that the ratios are common, the ratios are the same. So what we actually do here is we equate our common ratios. How do we get the common ratio? The second term subtraction the previous term, the following term subtraction the following term divided by the previous term equated to the other following term divided by the previous term. So that is a ratio. When we say the ratio is common ratio, you equate your common ratios because they are the same, they are common, you see. So now, what is our term 1 is this one, term 2 is this one, term 3 is this one. What is our term 2? Our term 2 is 2x minus 6 divided by term 1, which is x minus 6, equated to term 3 is 5x plus 3 divided by term 2 is 2x minus 6. Then we just gonna cross multiply in order to solve for x, right? Okay, so we're gonna cross multiply. So the 2x and the 2x goes together. Let me put them in bracket. 2x minus 2x multiplied by 2x minus 2x, and we have the x minus 6 being multiplied by 5x plus 3. Okay, so 2x and 2x, we're gonna multiply each of the terms with the other terms there. So 2x times 2x is gonna be 4x squared. 2x times minus 6 minus 6x minus 6 times 2x minus 12x minus 6 times 2x minus 12x minus 12x minus 12x minus 24x minus 6 times minus 6, it's positive 36, right? Okay. Sorry about this. So we have x times 5x, it's gonna give us 5x squared. X times 3, it's gonna be 3x. Minus 6 times 5, it's gonna be minus 30x. Minus 6 times 3, minus 18. So we can quickly simplify that one. 3x minus 30, it's minus 27x. So here we'll have minus 27x minus 18. Okay, so we can group the like term together. We can take this one to the other side, actually everything to the other side, and let's see how it goes. So we have 4x squared. We take 5 to the other side, it's going to be minus 5x squared. We have minus 24x here. We take negative 24, it's going to be negative 27x, it's going to be positive 27x, plus 36 minus 18 to the other side is going to be plus 18. Therefore we'll be left with 0. Minus 4x squared minus 5x minus x squared minus 24x plus 27 is positive 3x, and 36 plus 18, I think it's gonna give us 54, positive 54, being equated to 0. Now from here we can use the quadratic formula in order to solve for x, right? We can simply use our quadratic formula. So quadratic formula, it says x equals to minus b plus or minus root of b squared minus 4ac divided by 2a. X equals to minus b, your b is positive 3, plus or minus root of b squared, it's 3 squared minus 4. What is your a? Minus 1. What is your c? Is 54 divided by 2 into our a is minus 1. Then we can solve for x, right? Okay, when we solve for x, we are getting x equals to minus 6, or x is equal to, let's see, x equals to minus 6, or x is equal to, let's see, positive 9. So we have solved for x, right? X equals to minus 6 or x equals to positive 9. So those are the values of x. Okay, let's take a look at the second one. It says if x equals to minus 6, right? State the first 3 terms of the sequence and the nth term in the form of Tn is equals to something. Okay, so they are saying if x equals to minus 6, let's take the first 3 terms of the sequence. So we want term 1, term 2, and term 3, right? So term 1 is x minus 6, don't forget. Term 2 is 2x minus 6. Term 3 is 5x plus 3, right? So they are saying is if x equals to minus 6, let's get this term. So where there is x, we're gonna replace by minus 6. So it will be minus 6 minus 6 minus 12. Okay, 2 into where there is x minus 6 minus 6. So 2 times minus 6 is minus 12. Minus 12 minus 6 minus 18. Minus 18. Okay, 5 into minus 6 plus 3. So 5 times minus 6 is minus 30, plus 3 is minus 27. Minus 30 plus 3, definitely minus 27. So those are the first 3 terms of the sequence, right? So let me write them in that order: minus 12, minus 18, and minus 27. Okay, they said also we have to determine the nth term in the form of Tn is equals to. So this is a geometric sequence. Don't forget, this is a geometric what? Sequence. So what is the nth term of a geometric sequence? Is a into r exponent n minus 1. So our a is our first term, which is equals to minus 12. Our r, we get it by saying the following term divided by the previous term. This must be the same as the other following term divided by the previous term. So what is our term 2? It's minus 18 divided by term 1 minus 12. This must be the same as minus 27 over minus 18, right? So minus 18 over minus 12 is giving me 3 over 2 that side. Let's check minus 27 divided by minus 18. It's also giving me 3 over 2. Thus, to confirm that indeed the common ratio is what? Is 3 over 2. So we can now determine the general formula or the nth term. So our Tn will be our A, which is minus 12, our R, which is 3 over 2, all exponent n minus 1. This is our general formula. Okay. Okay, great stuff. Let's now look at this other problem. Very interesting problem. Um, Highly likely to be present in most of the exam, and it's quite interesting but very simple. Okay, the question goes like the second term of a geometric sequence is minus 4. How can we represent this? Term number 2, which is the second term, is minus 4, right? And the fifth term is 32. This is term number 5. It's what? It's 32. So the question says, determine the formula of the nth term of this sequence, that is Tn. Determine the formula of the nth term, right? So we know Tn, we are given that this is a geometric sequence. So Tn is A into R exponent n minus 1, right? So from this given information, you can see that we really need to express these terms in terms of A and R so that we can probably solve this equation and solve for the our unknowns, our A and R, so that we can go back and replace them in the equation to get that nth term. Okay, so the question is, how do we express terms in a geometric sequence in terms of A and R, right? So if you remember the other slide where we showed you how to get the next term in a geometric sequence, so it can be easy for you to identify that. So we said the first term is A, then to get the next term we multiply the previous term with a common ratio. So it will be A times R, which will be AR. Then to get the other next term, we go to the previous term, which is AR, we multiply with a common ratio. So it's AR times R, R and R will be R squared. So it will be IR squared. So to get the other next term like that, we multiply the previous term with a common ratio R, AR squared times R, R squared times R, R exponent 3. So we have AR exponent 3. Going like that, right? So this is the first term, second term, third term, and the fourth term. And you can now see the trend, sort of like, just as in an arithmetic series, in an arithmetic sequence, we also saw the trend of how they express terms, right, in terms of A and D, that side, but this side is in terms of A and R. So if it's term number 1, it's AR exponent 0, really, because R exponent 0 is 1 and it will still remain A, right? So if it's term number 2, they say AR exponent 1, right? It's like they're going back on an exponent there of R, like it's n minus 1 from that. So term number 3, it's AR exponent 2. Term number 4, it's AR exponent 3. Even if they want term number 7, you can know that it's AR exponent what? 6. Term 100, it will be AR exponent 99, right? So you can see this trend. So after knowing this trend, we can now go back and express those given terms in terms of A and R and see how we can solve them, right? So term number 2, it will be the same as AR exponent 1, right? Is equals to minus 4. This is our equation 1. Term number 5, it will be the same as AR exponent 4 being equated to 32, and this is equation 2. So in solving this, one can use a simultaneous equation to say, I'm going to form equation 3, substitute equation 3 into equation 2, like that, but that can take a bit of time, right? So in a geometric sequence, what you can actually do is you check which equation has the highest exponent, right? Is it equation 1 or 2? We can see it's equation 2 because we have AR exponent 4. Here we have AR exponent 1 in equation 1. So the one that has a highest exponent is gonna be divided by the equation that have the lowest exponent. This is one of the most fastest method that you can use in a geometric sequence. You don't do this in arithmetic sequence. In arithmetic sequence, just use your simultaneous equation. But here in a geometric sequence, you can actually do this in order to solve this equation fast. So the one that has higher exponent is equation 2. It's going to be divided by the one that has a lower exponent, which is equation 1, right? So we are saying AR exponent 4, which is equals to 32, is going to be divided by AR, which is equals to minus 4, right? So you just divide those terms that are really facing each other on top and below. So A will cancel A because you are dividing those things. R4 divided by R, it will give you what? It will give you R4 minus 1, which is probably R exponent 3. R exponent 3. Being equated to 32 divided by minus 4, we say 32 divided by minus 4 is going to give us what? Minus 8. Then we can now solve for R. You see now, it's really simplified. You're just left with R and you can solve for R there. So to solve for R, we have R exponent 3. To cancel that, we're going to apply the cube root to both sides, right? The cube root of R exponent 3, the cube root of minus 8. Then we can solve for R. Once we apply the cube root there, 3 divided by 3 cancels. We are left with R. Then we have the cube root of minus 8. It's going to give us negative 2. So we got our R. Our R is what? Is negative 2, right? R is negative 2. After getting R, we can go back to any equation that is like simple in order to solve for the other unknown, right? So we are going to say we are going to substitute our R, which is equals to minus 2, into the simplest equation. I think equation 1 is the simplest. So I'm going to substitute my R, which is equals to minus 2, into equation 1 so that I may be able to solve for A, right? Remember, we need A and R so that we can get this and a formula. Okay, so where there is R, I'll replace by minus 2 and solve for my A. To solve for my A, I divide both sides by minus 2. This cancel this. My A is gonna be equals to what? Gonna be equals to 2. Now I can get the formula, right? Let me just use a different color. The formula, the general formula, it's gonna be Tn. We know Tn is equals to AR exponent n minus 1, right? So that's the general formula. So our A, we got it as 2. Our R, we got it as minus 2 exponent n minus 1. So this is what our nth formula. So very important information to take from this example is that if you are given the geometric sequence and like the terms in terms of numbers, and they want something else that require you to solve this thing, maybe simultaneous or so on, in a geometric one, just know how to express the terms in terms of A and R, the terms in terms of A and R. After that, you don't really, you can use simultaneous, you'll still get the same answer, but the time you'll take a bit of time to solve it, right? So it's better to use this method. To say in a geometric sequence, I'll just say I just check the equation that has the highest exponent, then I divide it by the equation that have the lowest exponent, then I cancel what I'm canceling. I'll be left with one variable, solve it, go back and substitute, solve the other one, then that's it. Okay, great stuff. Let me give you some time to answer this fun activity. It's actually now time to engage, and let's see who can solve this. What you can actually do, here's the question. You can pause the video now and just try to answer this question. Drop your answer on the comment section. and I'll respond as fast as possible. So it says the first three terms of a sequence 2x, y, 9 form a arithmetic progression. Don't be confused by the word progression. Just know it forms an arithmetic sequence. And the last three terms form a geometric sequence, right? So determine x and y if and state the arithmetic progression, the arithmetic sequence, and also state the geometric progression or the geometric sequence in each case. So here they want you to solve for x and y using both your knowledge for arithmetic sequence and geometric sequence. So now you have to be thinking, how do we solve for unknowns if we are given a geometric sequence? How do we solve for unknowns if we are given an arithmetic sequence? So just pause the video, try to answer it, and drop your answers on the chats. Okay. Okay, great stuff. This marks the end of our lesson, and thank you very much for watching. Thank you very much for joining. Don't forget, this was session 2 of 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 patterns, sequence, and series grade 12 mathematics head start. That's all for me, and enjoy the rest of your day. Goodbye.